For those who don't know, more than 1,400 years ago, something happened to the world's climate that people back then couldn't explain. In 536 people in Europe, the Middle East, and some parts of Asia noticed that the sunlight suddenly became dimmer. It could still be seen in the sky, but its rays were pale and dim. It was like the sun was covered by thick clouds, even though there was no storm coming. The Roman historian Procopius wrote that the sunlight was almost as dim as the moon. Cassiodorus reported that its heat was weak. There were few shadows even at noon, and it seemed like the normal flow of the seasons was disrupted. The sun did not completely disappear. What happened was that there were so many tiny particles in the upper atmosphere that blocked part of its rays. Because there wasn't enough heat reaching the ground, the weather suddenly turned cold. There was frost even though it wasn't winter. In some places, the crops were destroyed before they could be harvested. When the harvest is small, the stored food runs out quickly. Prices go up, people go hungry, and they become more vulnerable to disease. It wasn't just one country that experienced this. There are old records from China about unusual cold, delayed harvests, and bad weather. In Europe, weak sunlight and cold summers were also reported. This shows that it wasn't just an ordinary local change in weather, but for many centuries, no one really knew what the cause was. There were no satellites back then, no modern weather stations. People also had no way of knowing if a major disaster had happened on the other side of the world. But eventually, they also discovered the cause. The evidence of what happened wasn't only found in old letters. There is also a clear trace of it inside the trees. Every year that a tree lives, it adds a new layer to its trunk. When the tree is cut down, these layers can be seen as a series of rings called tree rings. When the weather is good and there is enough water and sunlight, the tree grows faster. Usually the ring it forms is wider. When it's too cold, dry, or the conditions are bad, growth slows down, the ring is narrower. Because of this, a tree is like a natural record book. Each ring carries information about the weather conditions. In the year it was formed, one of the leading researchers studying this was Mike Bailey from Queen's University, Belfast. He started in physics before working in dendrochronology, the study and dating of tree rings. His team combined patterns from living trees, old wood and buildings, archaeological sites, and oaks preserved in wetlands. When the pattern of wide and narrow rings from two different pieces of wood matches, their records can be connected. In this way, they were able to create a continuous timeline that goes back thousands of years into the past. When they examined the part of the timeline that corresponds to the middle of the 6th century, they noticed something clear. The rings of Irish oak suddenly became much narrower in 536. There was a slight improvement after that, but it dropped again in the following years. This means that a significant event prevented the normal growth of the trees. And this problem was not only seen in Ireland. There are similar signs in the tree rings from Finland, other parts of Europe, Siberia, and North America. In Chile, there was also a significant decrease in the summer growth of trees. These places are far apart. They don't have the same climate, and they don't have the same type of trees. But they all showed signs of severe stress at almost the same time. In some samples, scientists even found what they call frost damage. The cells that usually form during cold weather appeared in the part of the ring that should have formed during the warmer months. It's a clear message from the trees. A sudden intense cold came at a time when it shouldn't have happened. History writer David Keyes noticed the importance of this evidence after he heard about the research on tree rings in 1994. He began to look for possible connections to droughts, famines, migrations, wars, epidemics, and the collapse of societies during the 6th and 7th centuries. He talked to many researchers from different fields and compared the scientific evidence with old historical records. Keyes believes that the climate disaster in the middle of the 6th century was one of the events that had a major impact on history. But we need to be careful with this kind of claim. It doesn't mean that a single climate event was the direct cause of every war, epidemic, migration, or the fall of a kingdom. During that time, many events in history had multiple causes. These included politics, economy, food, disease, trade, and the decisions of leaders. However, modern research clearly shows that there was indeed widespread and severe cooling. According to the current explanation of many scientists, large volcanic eruptions are the most likely cause. When a massive volcano erupts, it can push sulfur gases high up into the atmosphere. There, these gases turn into tiny aerosols that can reflect part of the sun's rays back into space. The whole world doesn't need to be covered by thick ash. It's enough for volcanic aerosols to spread in the upper atmosphere to weaken the sun's rays and lower the temperature over a vast area. Ice cores and tree rings show that more than one eruption may have occurred. There were major eruptions around 536 and 540, and possibly another one in 547. Because these happened one after another, the climate didn't return to normal right away. A longer cold period began, which some researchers now call the Late Antique Little Ice Age. It's still not certain which volcano caused the first eruption in 536 different locations have been suggested, but there is still no single answer accepted by everyone. So it's not safe to say for sure that Krakatoa or any particular volcano was responsible. What is confirmed is that there was very intense volcanic activity that released a lot of sulfur particles into the atmosphere and caused severe cooling in the northern hemisphere. In Ireland, this period coincided with the increase in the construction of crannogs. These were dwellings or defensive places built on small artificial islands in lakes. Bali suggested that this may be related to the unrest caused by food shortages and harsh conditions. When the harvest fails, people may be forced to rely on fishing, hunting, and any food they can find nearby. But crannogs alone are not enough to prove that climate is the direct cause of all conflicts. It's also possible that these were built for security, power, shelter, or other local reasons. Now let's delve deeper into the story. The clearer part of the story is the next problem. First, the sunlight weakened, then came the intense cold and the destruction of crops. After that, there was a shortage of food and greater pressure on the communities. And just a few years after the climate crisis began, the plague of Justinian arrived in 541. It spread throughout the Mediterranean and other regions, while many societies were already facing hunger, chaos, and a weakening economy. The people who lived back then did not witness the eruption that caused the disaster. They also didn't know that tiny particles from a distant volcano could spread through the atmosphere and change the climate of many countries. All they saw was a day that lost its usual brightness and a world that suddenly became colder, hungrier, and more dangerous. Despite this, as harvests declined, there was a powerful empire in the midst of great change. This is the Eastern Roman Empire, also known as the Byzantine Empire. Rome had long ceased to be its center of power. The new capital was Constantinople, a wealthy city located between Europe and Asia. Many ships, merchants, soldiers, food, and goods from different parts of the world passed through here. At that time, Emperor Justinian was the ruler. He wanted to bring the former territories of Rome in the west back under the control of the empire. His military campaign was extensive. His government had many projects, and the construction of large buildings continued. But while he was trying to strengthen the empire, there was a strange event in the sky that people living at that time noticed. One of them was John of Ephesus, a Christian bishop and historian. According to what he wrote, the light remained weak for many months. It could only be seen clearly during certain parts of the day, and even then its rays were still pale. He was not a modern scientist using instruments. He was someone describing what his generation saw and experienced. There is a similar account from Cassiodorus, a Roman official who lived in Italy. He wrote that they went through a spring that had almost no normal warmth and a summer that remained cold. The farmers were worried because of the continuous cold wind and the high possibility of frost. This caused their crops not to grow. These reports are important. This report is important because ancient writers did not usually record every change in the weather. When they wrote about a natural event, it was often because it was unusual and had a significant impact. There was another Roman historian named Procopius He said that the sunlight was unusual and seemed to have no strength. At the same time, war and other problems within the empire continued. When you combine the writings of Procopius, Cassiodorus, and John of Ephesus, it turns out that this was not just a simple cloudy week or an ordinary cold season. This was experienced for a long time in distant parts of the Mediterranean and the Middle East. And it's not just Roman records that tell this story. In East Asia, there are also records of extreme cold, crop failures, unusual dust falls, and food shortages. There are reports from China describing yellow things falling from the sky like snow. It's not certain if all these reports refer to the same kind of particle. It's possible that some were dust storms, volcanic material, or other local weather events. But the simultaneous emergence of problems with food and climate shows that widespread changes are happening. In Japan, an ancient decree shows how important food was during times of crisis. Its point is simple. Gold, money, or precious stones have no value to a person who is hungry and cold. This shows that the problem is not just about the unusual color of the story. The greater danger is on land. When the harvest fails, there isn't enough grain for families, soldiers, and cities. When the supply decreases, prices go up. The rich can still afford to buy, but the poor are the first to go hungry. In large cities like Constantinople, food must continue to arrive from other places. When there are problems with production, shipping, or trade routes, a lot of people can be affected. This is where it became even more important. The question is, what could cause unusual conditions at the same time in distant regions? Back then, some researchers discussed three major possibilities. It could be an asteroid, it could be a comet, or it could be a very powerful volcanic eruption. At first glance, an asteroid or comet seems possible. When a large object from space collides with Earth, it can be shattered and throw a huge amount of rocks, soil, and debris upward. When these reach the upper atmosphere, they can block part of the sunlight. This is one of the reasons why the impact theory has been studied for a long time. But the object that hits needs to be extremely large to affect the climate of many regions for a long time. An asteroid is a large rock orbiting in space. A comet, on the other hand, is made up of ice, dust, and rock. When it gets close to the sun, its surface heats up and forms the bright tail that can be seen from Earth. When a massive asteroid or comet hits the ground, its effects won't just be a dimmer sun. It will leave a huge crater, cause a massive explosion. Vast areas will experience intense earthquakes, and communities near the impact site could be burned or destroyed. If it crashes into the ocean, it could create a massive tsunami, with waves hitting the coastlines and leaving clear signs of widespread destruction. But there is no known crater from the 6th century that is large enough to explain the cooling that happened then. There is also no clear archaeological evidence of a simultaneous massive tsunami on the world's coastlines during that time. And even though many ancient records talk about weak sunlight, cold, and food shortages, they don't have a clear description of a massive object falling from the sky. It's hard to imagine that an impact strong enough to change the climate would go unnoticed by any civilization. Some researchers have previously suggested that maybe the comet exploded above the atmosphere and didn't reach the ground. In this situation, there might not be a large crater. But this remained a hypothesis. It didn't have enough physical evidence to become the main explanation. There are old studies that discussed a possible comet event, but stronger evidence was later found for volcanic eruptions. There's another problem with the impact theory. An asteroid or comet collision usually leaves special materials on the ground. These may include high amounts of certain metals, shocked minerals, tiny pieces of melted rock, or particles that came from space. So far, there's no clear layer from the mid-6th century that proves a massive cosmic impact. Meanwhile, other materials have been found in ice from the same period. Sulfur. In ice cores from Greenland and Antarctica, scientists found layers that show there were major volcanic eruptions in the 6th century. An ice core is a long piece of ice taken from the deep parts of a glacier. As snow accumulates each year, Tiny particles from the atmosphere get trapped and stored inside it. It's like a long record of Earth's past atmosphere. When a layer shows a lot of sulfate, it's a strong sign that there was a major volcanic eruption during the time that part of the ice formed. This is the kind of evidence the asteroid theory can't provide. It's not just that there's dust in the atmosphere. Its chemical signature points to volcanic activity. According to modern research, there are clear volcanic signals connected to the severe cooling events in 536 and 540. These eruptions are a better match for the records of dim sunlight, cold summers, and subsequent problems with plant growth. It doesn't mean that the Romans saw the actual volcano. It could have been very far from Constantinople in Italy. It's also possible that people in the area of the eruption didn't know how widespread its effects would be. All the people in the Roman Empire saw was the result: strange skies, cold weather, and increasing danger to their food supply. The list of possible causes gradually became smaller. There was no large crater, no clear record of a world-changing impact. There was not enough evidence of a massive tsunami, but there was sulfur in ancient ice and matching climate records from many regions. So as the asteroid and comet theory weakens, one explanation grows stronger. A massive volcano erupted, but its exact location remained a big mystery. But not all questions disappeared right away. There was another theory back then. Maybe it wasn't a whole comet that hit the Earth. It's possible it broke into many pieces and exploded simultaneously in the atmosphere. This is called an airburst. One example is the Tunguska event in Siberia in 1908. Something from space exploded before hitting the ground. It didn't create a huge crater, but the shockwave knocked down a lot of trees. Because of this, Mike Bailey thought that maybe many comet fragments exploded at the same time in the 6th century. If, in the study, and the amount of small particles left in the atmosphere could block some sunlight. He even tried to connect the theory to legends about King Arthur. In some stories, it's said that his kingdom became dry and devastated, while destructive things were falling from the sky. But this kind of evidence is weak. The stories about Arthur were written and changed over many centuries. It's also not certain if he really existed or when he died, and which of the details are truly accurate. That's why the legend about the comet can't be considered solid proof. Physical evidence is more important, like samples from ancient ice. No sufficient traces of cosmic material were found to prove a widespread comet bombardment. So while the research continues, this theory became even weaker. Now the search has shifted to a more difficult question. Which volcano erupted? During David Keyes' initial investigation, he believed that the most likely candidate could be in the tropical part of the world. A powerful eruption near the equator could spread volcanic aerosols across a vast part of the atmosphere. There are many large volcanoes in Southeast Asia. You can find them from Sumatra and Java all the way to the Philippines and Japan. Because of this, Keyes studied them. The old records from the region include a Chinese record from 535 that says a very loud sound was heard coming from the southwest. There was no record of lightning or an ordinary storm happening at the same time. It's possible that a very powerful volcanic explosion could be heard from far away. As the sound wave travels, the high and sharp sounds disappear. What remains is a low rumble, like distant thunder. But one sound is not enough to determine where it came from. Keyes also found a story from a collection of Japanese chronicles called the Book of Kings. It described loud thunder, shaking of the ground, intense darkness, storms, and great floods. The story also says that a large landmass was split and the gap between Java and Sumatra was formed. For Keyes, this could be a memory of a massive eruption. And between Java and Sumatra, there is a well-known volcano, Krakatoa. Krakatoa is famous because of its eruption in 1883. Its explosion was extremely powerful and caused massive tsunamis. More than 36,000 people died, most of them because of the waves that hit the coasts. After the eruption, a large part of the volcano collapsed. In the following decades, a new volcanic island rose from the sea. It was called Anak, Krakatoa, which means child of Krakatoa. Because of the magnitude of its previous eruption, researchers began to consider it possible that maybe an even bigger eruption happened there in ancient times. Thick volcanic deposits were also found around Krakatoa. These may have come from an old eruption that was even stronger than the one in 1883. A research team went to the islands to search for charcoal between the volcanic layers. Charcoal is important because it forms when wood burns quickly and gets buried. It can be subjected to radiocarbon dating to find out when the eruption happened, but it's hard to find. A large part of the ancient volcano is underwater. Only small areas can be excavated. In the active parts, trees don't always have time to grow for long before being buried by new volcanic material. The team was able to collect some charcoal samples, but they didn't find enough samples from the main eruption layer itself. What they got were from the layers above and below it. The layer above is estimated to be from around 1215. The deeper sample, on the other hand, is from around 6600 BC. This means the eruption falls within a very broad time range. This includes the 6th century, but this does not prove that the eruption really happened in 535 or 536, as the old documentary claimed. The results seem to further strengthen the Krakatoa theory, but the evidence is not that strong. The gap between the dates is too wide, as if saying there was an event that happened sometime within a span of thousands of years. That's not enough to point to the exact year or even the exact century. There's also a problem with the Book of Bucod, the version used in the theory. The theory was only put together in the 19th century, although it may have been based on much older stories. It's not clear how accurate the date is and which details are truly ancient. There are researchers who also said it may have been wrongly moved to 535. Because of this, modern science does not consider Krakatoa proven to be the cause of the first major eruption. More recent geological studies in the Sunda Strait have not found strong evidence of a massive Krakatoa eruption during that time. So it's incorrect to say with certainty that Krakatoa erupted in 535. The more accurate answer is this. It's still not certain which volcano caused the first eruption in late 535 or early 536. There are new studies that indicate there may have been more than one eruption. These happened almost consecutively. It's possible that several volcanoes in the northern hemisphere erupted at the same time or close to each other. And the problem didn't end there. Around 540, there was another very powerful eruption. It most likely originated in the tropics, and this made the cold period last even longer. At one point, the Ilopango volcano in El Salvador was identified as the possible source of this eruption. Some research dated its massive eruption to 539 or 540, but more recent studies have dated it to around 431. This means there is still debate about the exact date of Ilopango and its connection to the second climate shock. What is clear is that the story is not just about a single volcano and a single eruption. It is more likely that a series of eruptions happened within just a few years, each one adding new volcanic material to the atmosphere before the effects of the previous eruption had fully disappeared. When a powerful eruption sends sulfur gases into the stratosphere, the resulting aerosols can stay there for a long time. If another eruption follows, it adds to the barrier against sunlight like a wound that hasn't healed but gets hit again. Because of this, the normal climate couldn't recover quickly. Cold summers continued, food production weakened, and communities had a harder time recovering. We also shouldn't say that volcanoes alone brought down kingdoms or started all the wars during that time. Each region already had its own production, power struggles, military conflict, high taxes, migration, and changes in trade. But the climate crisis made many of these problems worse. When food is scarce, unrest is more likely. When the economy is weak, it's harder to fund the army and government. When people are hungry and weak, they get sick more easily. And when these things happen at the same time in many places, the course of history changes. The most important discovery in the mystery of the 6th century is that a comet was not proven to be the cause, nor was Krakatoa proven to be the only culprit. The strongest evidence points to a series of large volcanic eruptions, including one still unidentified eruption in 536, and another very powerful eruption just a few years later. We may not yet know the names of all the volcanoes, but their effects are clear. In just a short time, eruptions in distant places sent material high into the atmosphere. After that, for many years, millions of people experienced cold weather, food shortages, disease, and unrest, even though they never saw and never knew where the disaster began. A distant volcano might not be visible from a city, but if its eruption is powerful enough, its smoke can change the lives of people all over the world.